Hello, my name's Simon. I'd like to introduce you to the way I've programmed this application you can see on the screen, which is the insides of a scroll expander. The scroll expander consists of two intermeshed scrolls or spirals between which pockets of gas are trapped as one scroll rotates against the other. So I'll show you that running. So that pocket of gas gets larger, it expands outwards as the scrolls rotate. There's the orbit of the rotation. And this is a way in which you can produce power by expanding gases or vapours through a scroll expander. So how it works and what it's for is not particularly important. It's more, for this case, how did I produce this simulation? How did I make this work? There are a number of key elements to making this work. One is getting smooth graphics, which you can then animate. So how to make them run smoothly without flickering away on the screen and so on. And the other is how do you handle the time slices to actually call the redrawing of the scroll to show it in motion. So how do you animate it? I'm just going to stop that and explain that this is all done in Java and the Netbeans environment. And to get there, to go in one leap into how this works is quite a big step. So I wanted to show you how I tackled these time and animation issues. These aren't necessarily the way to do it, they are a way to do it. So please don't tell me 8,000 different ways to do this. This is just to help people get into the Java Netbeans environment. So the first thing I'm going to do, rather than dive into the scroll, let's just close that one, is look at an application called Stopwatch. It's a very simple application. If I run that, it counts up in hundredths of seconds. I can stop it, I can start it, I can reset it, etc. And of course I can exit. So that's the first stage. It's a very simple program to show you how the environment is used to build something like that and how we handle time. It's not actually that straightforward. Let me take myself off screen first and we'll start a new project to show you how this is done. So this is within the Netbeans environment. If you don't know about Netbeans and Java, then there's plenty of other YouTube videos that will introduce you. This is actually, just to be clear, I am using Java 8 from Oracle, which is free at the moment, but not necessarily always going to be, and Netbeans IDE 8.2. You need the Java SE bit. Okay, let's get rid of those two. So we're creating a new application, Java application. It's by default called it Java application 14. I'm going to stick with that. And it creates for you a very simple program. Here it is. It's Java application 14 is the package of all the parts, the libraries, etc. A public class called Java application 14, which has a main program in it, which will be familiar to people using Java or C. And I can do things like write from this to the input-output to the command prompt, if you like. Just to prove that, let's just print hello world. Everyone else does. Exclamation. If I up here, I've got compile tools and a run tool. If I click run, that will compile and run it. Well, it's run. It said hello world on the command line because I asked it to print out on the system output. It's worked. This isn't really very useful for what we want to do. We want a graphical user interface where we interact with the buttons, the run, stop, reset buttons you saw and the exit buttons. So here's a strange step. Here's the source file, Java application 14, and that's the package, Java application 14 above it. If I right click on that and say new, I can create what's called a J-frame form. So it's a new frame, it's a J-frame form, and let's just call it Stopwatch. I think it'd be okay about that. Yep, there we go. So there's the graphical user interface, and behind this, up here we can go between the design what we see on screen and the source, this code behind it. So it's exactly the same as the previous one. It's got a package of files. It's got a stopwatch, which now extends the generic form JFrame. And it's got a few more bits and pieces in it, because in here is some hidden code which has been put in by the system, and this actually generates the graphical user interface for us. We still have main, that's still the entry point to the whole program, but all it does is it brings up that graphical user interface. Then the flow of operation goes down to the buttons. We've now got two main programs, which isn't permitted. So again, another strange step here. The next thing we need to do is go to that original one and delete it. Okay, delete. I'm using something called safely delete. That gets rid of any connections it had to anywhere else in the package. Refactor, no idea what refactor means. It just gets rid of it. So we now have one main loop. There it is. One main, one entry point, which is in stopwatch.java. So we go back to the design. At the moment, it's a blank screen. We want to do something. So I'm going to put a button on here. And the first button to put on it is an exit button. So a button, it's called JButton1, is an instance of the graphical object JButton. And it has properties, has the bindings, where it belongs to, events, what to do when its mouse goes over it or clicks it, etc. And the top level code, what it's called. And you can do things like here, I can change it from being JButton1 to be exit button, which is handy. You'll see why later on. So it's now called exit button. I go back to its properties. I want its text to say exit. Okay. Now I could go into its events and decide what to do when it's pressed, but there's a nice shortcut here, which is that you double click on it, takes you straight into your coding again, and brings up what's called a handler. So this is handling the button press. And at this point, I just want to exit. So system, here's all the things you can do with system, and one of which is exit. And I'm going to give it a return code of 0. We don't need a return code really, but it has to have one. Okay, so we've got our program's actually doing something now. If I run that, first time I try running it, it says which one am I going to run, because I had two mains. So just once and once only say yes, it's the one called stopwatch. And there it is. That is the program running. It only has an exit button at the time being. If I click exit, it stops. Great. So now if you recall, we're creating a stopwatch. So we need three buttons, a run, a stop, and a reset. So let's put those buttons down. And the first one is run. And we'll change its name to be run button. It's quite useful because we have to access it in the code. We could leave it as JButton1, an instance of JButton, but it gets a bit messy. It's nice to give them a proper name. Second button, which says stop, I'm going to call that stop button 1. That's just stop button, sorry. Proper name and its text and the properties. The properties are the values of that belong to the class JButton. So these are things like the text, how it looks, how it appears, what size it is, everything really. But one of the most important ones for us, of course, is what it says, which is what it's going to do. So it's going to be stop, it's going to be run. One last button here to put down, which is reset. Okay, and if I go to the code for reset, I'm going to call that reset button, just so it all corresponds now. Oops. Reset button. Okay, so three buttons. I now need somewhere to output the information. I'm going to use a text field. I could have used a label as well, actually, because it's going one way. You see how it helps you line things up as you put it in. Again, you're going to recall it. It's going to call it counter text field instead of JText field 1. I'll get hold of it, I will. Counter text field. And in the properties, the only thing I'm going to change here, well, two things. I'm going to give it no default text because we're going to program that. It will change as it works. And I'm going to use a different sized fonts as default. So I'm going to use 36 bold Tahoma font here. Okay, so that's all set up. So following the same route we did for the exit button, double click on run, and we're down to the handler now. There's the exit one we did before. Here's a new one. It's saying this is what we do when the run button is pressed. So the first thing I want to do is set up a timer. So class timer, my timer equals new timer. Okay. We get squiggly lines, red squiggly lines, are telling us an error or something's unresolved. In fact, in this case, it's telling us couldn't find the class timer. Some things you can use fix imports, but here I want to use a library called util. So I have to import those classes. So it's within the package, but outside the class stopwatch. So down here, I want to say import java.util. There's loads and loads and loads of these libraries. Some of them will be obvious, some of them will be resolved automatically. Some you just have to search your way through Google, find the one you want. So here's timer, or any other browser, of course. And because I know we're going to need this in a moment, I'm also going to import type util timer task. So those are the two things I need to set up a timing loop. All this grey text here is the text being created by the system to generate all these the pictures of the buttons, etc. So now you'll see the red squiggly lines have gone. It's been resolved. There's a grey squiggly line which is basically telling me it's not yet been used. So it's an unused variable. So if I now create a timer task, my task equals a new timer task. This is where it gets a little strange. So we'll have to take my word for some of this as we get it going. Timer task, we're defining what that timer task is within its own code. So I'm going to use public void run. So this is handy bit of code. You can use it elsewhere as well, which says anything in here will be run when you get to this line. And I want to run, so get rid of that red squiggly line, put a semicolon on it, that finishes that one. I want it to run a program that updates, there's the R timer, there we go, that updates the screen every time this timer is called. So before we go any further, let me create that subroutine. Oops. Public. I'm going to make it a Boolean. It's going to return a value. So update. Doesn't take any arguments, but oops, get this right. Squiggly bracket, there we go. We've just created a new, oops, again, it's not recognized. Public, there we go, small p. It's created a new subroutine. It's going to return a value. So for the moment, I'll just make it return false. It's a Boolean value. And in here, I'm going to add some code which will update the counter text field. Dot. And these are all things I can do to the counter text field. And I actually just simply want to set text. There we go, it's come up there, which takes a string. Now, I want it to print out a count, how many times we go through. So let's just create a global variable so we can access it every time we go through update. It's a long integer called counter. Just set it to 0 there. Okay. So in here, I want to display this with fractions, so hundredths. So we're going to call this every 10 milliseconds, and we also want to see hundredths of seconds. So I need to give it double dot to string. Some of this formatting will take too long to explain. Use it as a starting point and then go and search for others. So you could also have integer to string, for example. Counter, divide it by 100, so we send it every 10 milliseconds. So that would work, but we haven't incremented counter. So we could say counter equals counter plus 1. There's a nice shorthand which just say plus plus. That says use the value of counter to display whatever you're doing, and after you've used it, increment it by 1. So this counter will tell us how many times we've been through the update program. Because I'm calling it every 10 milliseconds, if I then divide that by 100, that will give me seconds with 2 decimal places. Great. So in here, I want to call update. There it is. And finally, to make this run program work, I need to connect together my timer and my task. So I'm going to give my timer a tick, a time to call timer task, which will then call update. So if I go to my timer dot, all the things I can do to it, here's one called schedule at fixed rate, and say when it starts and then how often it repeats, or say what period it repeats at. It's automatically picked up my task, which is handy. It's not always that great at picking up the right things, but sometimes it's helpful. Let's say 10 milliseconds till the first time we call it, and then every 10 milliseconds thereafter. So this, what we now have is a timer defined, a timer task, and we've told the timer to call itself every 10 milliseconds and call this bit of routine, which will run and then call update. Okay, and update, we've said, will display the current time to hundredths of seconds. And in fact, if we run this now, we will be able to see that run, but we won't be able to stop it. Let's just prove that. There's our thing. Click run, and away it goes. We can't stop it. We've not got any mechanism to stop it at the moment. We can exit though, of course. Okay, so in order to stop, this is where a bit of fun comes in. We can only define timer locally, because when we kill a timer, we cancel it, we can't then reset it, restart it. So it has to be just a local variable, and every time we press run, we start a new local variable. So I create a global here called, it's going to be a Boolean, called stop timer. We'll start it off as being false. Okay, so don't stop the timer. And every time we're in update, the first thing we do is say if that value is true, then I return true. So what I'm doing here, I'm saying check this flag, stop timer. If it's true, then return true. Don't bother updating the screen. If it isn't true, then carry on. We'll update the screen and we'll return false. So we've got something we can pick up here. So if we now say if update, so if it's true, it's telling us to stop running. So in here, we want to say my timer dot cancel. And that will stop it. So we now have a way of stopping it. I'll just carry on for a moment, because what we want to do is how do we set that stop flag? And the answer is quite straightforward. We want to go through the stop button. Okay, so if we go to the design, double click on stop, and in stop, which you set icon past, there we are. The main thing we want to do is say stop timer equals true. Okay, that will now stop it from running. So very quickly to prove that, click run to run, stop to stop. I won't be able to restart it because there's a couple of bits missing, but we can run and start, stop and start it once at the moment. In here, if we cancelled it, the flag is still true. So once we've stopped it, we want to reset that for the next run. So we want to say stop timer, that's the flag, equals false. So it's ready to rerun. So we now press run again. We also want to do a little bit of housekeeping here. That once we've stopped, we don't want to be able to stop the stop button again. So stop button dot set enabled is the one we're after here. It says, does it work? Or you can see it, but it won't work if it's false. So we're saying we've already stopped it. We've got nothing running at the moment, so you can't see the stop button. Likewise, after we've set up the initial timer, we've clicked run once. We don't want to click run again until it stops. So we can also say here, run button dot set enabled equals false. But likewise, if we've stopped it here, so we know we've stopped, we want to be able to restart. So run button dot set enabled is true. See, so what we're doing here is toggling between the two. It sort of cleans it all up a bit. I've misspelled false. It's showing me with squiggly lines. And likewise down here, because we've started, we're now running, we want to make the stop button dot set enabled equals true. Fantastic. There we go. So we can now toggle the buttons. And there's only one thing we really want to do to complete this whole construction is be able to reset. So go to reset, double click again, brings us into another handler for the reset button. In here, it's very straightforward really, we just want the counter to equal 0 again. So just restart it. There is, however, one last thing we want to do here, because if you're stopped at the time, you won't get to see that it's been reset. So I'll copy through here the line which displays to say it's gone back to 0. Whoops. So that just redisplays it if it's already stopped. That should now be the entire program. The reset can happen at any time. So here we go. Let's prove it. We can run. We can stop. You see how the buttons are graying out, so we can't stop a second time after we've stopped. We can run. We can't run a second time until we stop again. Okay, so we can stop and start. The counter isn't reset. We press reset, it goes back to 0. We run it. We can also press reset whilst it's running. That's it. We've created the timer. There's all sorts of cleaning up we can do, and formatting the size of it and so on. If you download the timer program from my website, let me show you where that's going to be, you'll be able to look at that in more detail. So you can get it from www.redford-tech.co.uk examples.html. You need to get that examples lowercase with the HTML on it. That's the only place you'll find that. There's no other link to this anywhere. And if you want to contact me, it's simon@redford-tech.co.uk. At this website, you'll discover that you can download this timer example. You can download the next one, which in the list is called Animate, which is to show you how to move things smoothly on the screen and how to get good quality graphics. Third one is a simple clock application, so you can it's got a few extra little bits and pieces about being efficient in graphics animations. And then the fourth one is the scroll expander itself. So you're quite entitled to download all of that code, see how it's done, expand it for your own use, etc. Each of those is provided as a zip file for the Netbeans environment and also as a .jar file. That's a runtime file for which you'll need the runtime engine downloaded as well. And that's different on different platforms. But the jar file is the sort of generic file of these examples. Finally, just to recap what we actually did here, because it's quite important. In terms of how I have come to the conclusion is the right way to run time in these Java applications. It's a bit different to some of the other environments like .NET, for example. When we get a run button press, that is then handled by a routine which sets up a timer and we set up a task. That task will call a program called update every tick of the clock. And We then define the tick of the clock, in this case to be 10 milliseconds. So it's quite fast. It's going every 10 milliseconds it will call my task, which we'll call update. In the update routine, or subroutine, we first check to see if a global flag has been set called stop timer flag. If it has, we return true, and that true status will be interpreted in my task to stop the timer, so to quit this particular run and exit the run program. If it isn't, then it updates the time and returns false. The only way of stopping this is if you press the stop button. So the stop button will set the stop timer flag to be true. And the only other bits in here are the reset, which is just resetting the counter to 0. And there's a bit of niceties added in terms of fading and re-enabling run and stop buttons to make sure you can't get multiple presses. That's just good programming practice, really. Okay, thank you very much for your time. The next program in this sequence will be the animation one, and it goes under the corny name of Annie Mate, as an Annie, a girl mate. You'll then find clock and then scroll itself. Look forward to seeing you in the next video. Thank you. Bye-bye.